Hi, and welcome to the 2018 Paper 1, Question 4. So, as usual, if you want to set out the notes I'm working off, please send me an email at shanetroy@gmail.com. The email address should be in the description below. So, question 4 here has statement F is the set of factors of 12. And we have an empty set here, a set with blank spaces, for us to fill in the first six elements of that set. Now, I suppose the first question is, what's a factor? Okay. Now, we should have some knowledge of what prime numbers are, okay, composite numbers, squared numbers, multiples, these kind of terminologies. This particular one is talking about factors, which is basically numbers that can be multiplied to give the number you're talking about. So the factors of 12 are, you would think of two numbers, okay, that can multiply to give 12, but it doesn't have to be two, okay. So basically, another way to look at this would be what numbers can divide into 12, okay, with no remainder. So I'll go with the answer here, okay. So the first one is 1. 12 can be divided by 1 evenly, okay. So can 2, so can 3, so can 4, so can 6, and 12 itself. Okay, now if we want to multiply them to give 12, you might just go straight. 3 by 4 is 12, okay, 2 by 6 is 12, 2 by 2 by 2, okay, is just 12. Okay, actually it's not. 2 by 2 by 3 is 12. So a definition, just to have the knowledge of it, is factors are numbers that when multiplied together can give the original number. Okay, so that's that. Now the next part here, part B, okay, is saying that set P and S are as follows. P is the set of all prime numbers. Okay, so a prime number, I have a definition here. It's a whole number which can only be divided by itself and 1. Okay, a prime number must have only two factors. Okay, that's part of the definition. Now, S is the set of all square numbers. Okay, all numbers enter power 2, where n is lambda of n. Okay, so it's a positive number. Okay, so the Venn diagram below shows the sets F, okay, which is our factors from part A, P, which is our prime numbers, and S is our square numbers. Okay, so we need to fill in this Venn diagram. So I'll go to the answer here. Okay, so I have the three sets written out. Okay, so the set of all prime numbers is 2, 3, 5, 7, 11. That's the first 5 prime numbers. Now 1 is not prime. Okay, since I always thought it was, but it's not. Okay. S is all the square numbers, so 1 squared. Okay. 2 squared is 4, 3 squared is 9, 4 squared is 16. Now we don't really need the 16 because it goes beyond our our range, okay? And F is 1, 2, 3, 4, 6, and 12. We identified that in part A. So where do things go? Okay, so we see, is there any commonality here? Okay, 1, okay, 2, 3, 4, 5. Something common to all three sets, so nothing goes in the middle here. Okay. Is there common between F and P? Okay, so between F and P, well, 2 is. Okay. 3 is. 5, 7, no, that's it. Because that's where the 2 and the 3 go in there. So they've been accounted for now. Okay, so we can just block them out, whatever we want to do it. Then what's common to F and S? Okay, so let's see. F and S of these two. Well, 1 is, okay, 1 and 1. 4 and 4. Nothing else, so 1 and 4 go in there. Now what's left in set F, okay, is 6 and 12 stays there. Okay. And I don't actually need to go any further because the question there says write each of the factors of 12, so I'm only really worried about these ones from part A into the correct region in the set F in the Venn diagram. So I'm only really concerned with the set F. I'm just deciding where I put them in terms of intersection, whatever, by writing out sets P and S. So I'm not actually asked to fill in these two bits here. Now, technically, P would be 5, 7, 11 will go in there. Okay, it's in set P, but not in F. 9 and 16 will go in here. If you were asked to fill out the entire Venn diagram, and there's no commonality between all three. Okay, so it's fairly decent. No one was paranoid that it seems too easy. Okay, anyway, that's question 4. So see you on question 5, and thank you.